Welcome back to Learning How to CAD with Autodesk Inventor. In this episode, we're going to cover 4 of the 5 constraints that are in Autodesk Inventor that you're going to need to build your robot in the CAD. So to start off, we're just going to make a new English assembly. Wait for it to load. Don't worry about the error. I deleted something I should know at some point. No idea what it was. And then just for a quick reminder, click this place button in the upper left, go to whatever folder you have, and then I'm just going to pick this file. Pick your files that you need, and then place. You can really place as many as you want. I'm just going to place 3 of those for now, and then right click OK, and then ground one of the files to keep your views square with each side. As so. So I'll be back in a moment. I'm going to quickly add some more files to this so that I can show you all the constraints in the fastest way. Okay, so you can see I've added a bunch of parts, these wheels, these axles, this channel, this C bracket I guess is a better word for it, and this C bracket. I've already added some constraints, but I'll go over each one that I've added. Like as you can see, this axle is not actually attached to this wheel yet. But first, so we're going to make a sort of a drivetrain. We're going to open our constraints button right next to joint in this upper bar. Pretty big button. I think you'll be able to find it. And then this first option, it's called mate. And then you have these 2 options here. We'll get into each one in a moment. So this first option, this one's just called mate. This will sandwich 2 parts together. So I'm not going to actually apply this, but as you can see, I clicked on this face and this face. And now the 2 parts are touching on those faces. So we're going to cancel that because I don't want that constraint. Go back to constraint. And this is the flush constraint. So with this constraint, we can click on this front face, and actually let's go to the top first. As you can see, the front face of this bar is not at the same level as the front face of this bar. So if we click on the front face of the first channel, we can then go click on the front face of the second channel, and they will become flush, which is why it's called flush. And then we can click apply, and we can do the same for the top. As you can see, they're at different heights, but if we click on the top and the top, they'll go to the same height. So that's the flush constraint and the mate constraint. These ones will be used a bit, but with Tetrix, the biggest constraint I use is insert because it's the fastest because of all the circles. This constraint only works with circles, but as you can see, if you click on the surface of one circle and the other circle, oops, kind of hard to see, the 2 surfaces will, the 2 circle edges that you click on will become flush with each other. And then this is flush, I guess, and this is more of a mate. We'll go look at that. See, it's on this side now. The wheel flipped itself. But we're going to go like this so that it's actually inside the wheel a little. And then click apply. So that will just make both of the circles concentric and then either make it flush with the first surface you selected or mate. So the 2 surfaces are touching instead of being flush with each other. So from there, that's with axles and wheels. You can also do it with all the circles that are on the Tetrix channels. And I'm going to place this right here and change the option so it's pointing the right way. Actually, I want to show another constraint later, so I'm going to change this. As you can see, I just click on these 2 mouse icons and it deselects what I've already selected. So I'm going to select that and then apply. And then you can do it the same with the C brackets. So you can go over here. And then if you go back to the mate option, you can select a circle, the axes of a circle, and then go select the axes of another circle, and it'll align them. If you're working with these C brackets, you'll need to do this because it's kind of hard to see. But the brackets don't actually fit perfectly inside of here, unlike how they do with the real-life Tetrix pieces. So you'll need to insert it to one side only, or insert it to one side and make a concentric mate to the other side. So once you've done that, let's just quickly add another insert. to right here. Oops. Let's see, where did we go wrong? Let's just try using our mate constraint. See if this works. There we go. So that worked. So I'm guessing it's just that the... Oh yeah, that's probably what it is. This piece is not on the same... So we inserted this piece onto this plane, whereas we inserted this piece onto that plane. So the centers of the C brackets aren't quite aligned, so the insert tool doesn't work in that instance. So, but if we just use the mate tool, it does the exact same thing because of the flush constraint we applied earlier. And then we'll check out this angle constraint. This, I generally just use this first option with the two surfaces. So if you click on your base surface, whoops, that's not the surface I wanted. Click on your base surface, and then go click on your second surface. It will make them parallel, or that you can do that with the flush constraint as well, if that's how the geometry works out. But let's just, for no reason at all, just make this 15 degrees. As you can see, it starts to angle the piece. That has a degree of freedom in that axis. Let's make it 20. As you can see, it's moving that way. Now it's a 90. It doesn't really look much different, but if we go to this side, you can see the opening is actually on this side now. And we'll just do that. And then for the wheels, it's kind of the same thing as putting the axle in the wheel. Just insert, do this, and then click on this hole. And this isn't going to work too well for a wheel, so we're going to actually add some space between it and this channel. So I'll go to this view so you can see it the easiest. And then let's, just so we can see the spacing, we'll say 1 inch. And as you can see, it moves that way. If you do -1, it'll move in. So we're going to do +0.5. There we go. And you can do that with all 4 wheels. But I'm not going to add an offset just so this is quicker. Right there. And finally, this wheel. There we go. So that is our very, very, very basic drivetrain. And then there's one more constraint I want to cover, especially with the specifics of this year's game. It's going to be the tangent constraint, but it really just helps. Mainly, it just helps you visualize different things. So I'm going to go cheat a little bit. I didn't actually put the ring in the folder I gave you guys, but we're going to go all the way out. Documents, GrabCAD, my team folder, and then I have this separate folder with just the ring and the wobble CAD in it. We'll throw a ring in here, and it's going to give me an error because I'm outside of the project folder that we made in the first episode. And then just go tangent, click on the outside surface, and click on this. And now you can see it is tangent with this face, and I can move it along it, and it won't go up or down. So now let's go, if you right click on the part and then click show relationships, you can see what relationships it has. And then if you double click, you can change the offset. Otherwise, right click on the constraint and click edit. And you can adjust more specific properties like this tangent. I want to flip it so it's tangent on the other side. And we'll just click OK. And then go up here to the bar again and click hide all right next to constraint. You can also show constraints from this button, and then, oh, let's do that one. And then it deselects after 1 though, because it's a little annoying. And then this is the symmetry constraint. I've never actually used this one. I have no idea how it works. But if you want to try and use this, go right ahead. I might try to learn it at some point. Maybe it'll be useful, but at this point, I've only ever used these 4. So that's it for this episode. In the next episode, we're going to go over some tips and tricks to use in your assemblies, like hotkeys and measuring tools.